Inside this hollow acorn, a baby is about to die by the jaws of its own nurse. The nurse is an ant. The baby is not hers. It belongs to the parasite that raided her colony, kidnapped her as a pupa, and chemically tricked her into raising its children. But tonight, that chemical lie begins to fail. Across the nursery, the stolen workers stop feeding the parasite's young. Then, they begin tearing them apart. This is not a rare accident. In some slave-maker colonies, enslaved ants kill up to 66% of their captors' pupae. And this is only one kind of ant. More than 15,000 ant species have formal names. They live in forests, deserts, kitchens, tree canopies, rotting logs, and chambers that no sunlight reaches. They outnumber humans by numbers the mind cannot hold. For every person on Earth, there may be millions of ants moving somewhere underfoot. Most look like dots, but each dot carries a different answer to the same question. How do you build a civilization when everything bigger than you can crush you? Some ants answer with farming, some answer with speed, some answer with chemistry, architecture, slavery, or self-destruction. The small world is not simple. It is older than our own. The ant in the acorn belongs to a system built on theft. These are slave-making ants, including Protomognathus americanus and Polyergus. Their raids begin with violence. Workers invade a smaller colony, kill the defenders, and steal larvae and pupae from the nursery. Those stolen young hatch inside the wrong nest. To an ant, smell means family. So when the captives emerge surrounded by the parasite's chemical scent, they accept the lie. They feed the parasite's larvae. They clean them. They carry food to adults that cannot survive without stolen labor. Polyergus workers carry sickle-shaped jaws made for war. Those jaws pierce other ants during raids. But the same weapons fail at ordinary life. Place a Polyergus worker beside food, and it may starve unless a captured worker feeds it mouth to mouth. The warrior wins the battle. Then it needs a servant to eat. Yet the stolen workers do not remain perfect servants. When the parasite's young become pupae, their chemical profile shifts. The slaves detect the wrong scent. They stop feeding them. They tear some open. A colony built on kidnapping now raises the hands that sabotage it. That ant solves survival through theft. Another solves it by making children into tools. High in the forest canopy, green leaves bend toward each other. Workers grip the edges and pull. The gap holds. The adults need silk, but adult ants cannot make it, so they fetch the babies. These are weaver ants, Ocophilus maragdina. A worker lifts a soft larva in her jaws and carries it to the leaf seam. Then she taps it with her antennae until silk comes out. She moves the larva back and forth across the gap, laying down thread like a living glue brush. If you held that larva in your hand, it would look helpless, pale, and unfinished. In the colony, it becomes construction equipment, not because the adults lack skill, not because the nest lacks workers, because evolution put the silk inside the young and the labor inside the adults. The leaves become walls. The larva gives up the silk it would have used for its own cocoon. The stolen worker in the acorn loses her life to another colony. The weaver larva loses its silk to its own. But some ants do not build with bodies. They build with crops. Across the forest floor, leafcutter ants carry green fragments above their heads like tiny sails. A trail of them looks like a moving garden. The first assumption feels obvious. They must eat the leaves. They do not. These are leafcutter ants, including Otta species. They carry leaves underground, chew them into pulp, and feed that pulp to a fungus. The fungus feeds the colony. The ants farm it in dark chambers that can reach 16 feet deep and 50 feet wide. A young queen begins this empire with a speck of inheritance. Before leaving her birth colony, she carries a pellet of fungus inside a pocket in her mouth. She flies, mates, lands, tears off her wings, digs into the soil, and plants the first garden with her own waste. Then, she stays underground for years. A farm this dense invites disease. A parasite called Escovopsis attacks the fungal crop. So the ants carry bacteria called pseudonocardia on their bodies. In plain language, they wear living medicine. Those bacteria make antibiotics that help protect the crop. The ants do not just farm. They farm the thing that protects the thing they farm. That is agriculture with a pharmacy built into the skin. The leafcutter turns plants into food without eating the plants. Another ant turns its own face into a weapon. A jaw can close in less than the blink of a blink. This is the trap-jaw ant, such as Odonomachus bauri. It walks with its mandibles locked open, sometimes near 180 degrees, waiting for tiny trigger hairs to touch prey. When they do, a latch releases. The jaws snap shut in about 13 milliseconds. The strike can accelerate at 100,000 times the force of gravity, and hit with more than 300 times the ant's body weight. That would already make it a precision weapon. Then, the ant points it at the ground. When danger gets close, the trapjaw ant slams its mandibles into the soil and launches itself upward about 8 centimeters. It spins through the air at high speed and lands away from the threat. If your jaw worked this way, you could bite the pavement and throw yourself over a building. The weapon becomes an escape system. The trapjaw ant uses speed to leave danger behind, but one ancient ant uses speed for something stranger. The fastest recorded movement in any animal does not come from a cheetah, falcon, or striking snake. It comes from a Dracula ant. Mystrium presses its mandibles together, building pressure until one jaw slips past the other. It works like snapping fingers. The strike reaches about 200 miles per hour and finishes in 0.000015 seconds. Too fast for an eye. Too fast for ordinary cameras. But speed only opens the door to the darker part. Many adult ants struggle with solid food because their narrow waist blocks it. Most colonies solve that problem with shared liquid feeding. Larvae digest solids, then pass nutrients back to adults. Dracula ants take a harsher route. Adults bite holes in their own larvae and drink hemolymph, the insect body fluid that works like blood. Scientists call it non-destructive cannibalism because the larvae survive. They survive with scars. Picture a parent unable to eat solid food, feeding a child, then drinking from the child's body after the meal becomes liquid inside it. That is the arrangement in the nursery. The fastest jaw in nature sits above a family feeding system that leaves the young marked. And still, speed and hunger remain personal. One ant can go further. It can turn the whole colony into a machine. When floodwater rises over a fire ant mound, the colony does not drown in place. It becomes a raft. These are red imported fire ants, Solenopsis invicta. Workers pour from the soil and lock together with claws, jaws, and sticky pads on their feet. Hundreds of thousands of ants flatten into a floating sheet. Their bodies trap air bubbles underneath, keeping the lower layer alive. Push the raft gently, and it acts solid. Hit it hard enough, and it flows. Not because a queen gives orders. Not because any worker understands the whole shape. Because every ant follows local pressure, grip, and contact from the ants beside it. When stress rises beyond a few times one ant's body weight, workers release and reconnect. The raft stretches around sticks and debris like thick oil, then tightens again. You are not watching teamwork. You are watching a living material. The trap-jaw ant turns one body into a spring. Fire ants turn thousands of bodies into physics. Yet a raft still needs water. Another colony abandons the nest entirely and makes architecture out of itself. In the neotropical forest, army ants can build a home without walls, soil, or wood. They use workers. Eciton and Labitus army ants form bivouacs, living nests made from hundreds of thousands of linked bodies. Workers hook their legs and claws together around the queen and brood. The structure shifts as the colony needs it. It also controls temperature. In Costa Rican montane forests, Labitus predator can warm the center of its living nest more than 6 degrees Celsius above the surrounding soil. Smaller workers move the brood through the living walls to keep eggs and larvae in the right conditions. A house made of bodies should fail. This one heats its nursery. Then it marches. A mature army ant colony can mobilize up to 2 million workers in a swarm raid. The front can spread across the forest floor, flushing out insects, spiders, and small animals. The workers carry food back into a nest that also breathes, warms, protects, and rearranges itself. Nothing in that path receives a warning. The army ant becomes a building. The fire ant becomes a raft. But another ant becomes a borderless empire. A worker from one continent can enter a nest on another continent and meet no enemy. This is the Argentine ant, Lenapithema humal. In its native South America, colonies can recognize rivals and fight, but introduced populations lost much of the chemical variation that marks colony identity. Their scent passports began to match. In Europe, one super colony stretches about 6,000 kilometers along the Mediterranean and Atlantic coasts. Billions of workers move through millions of nests without internal war at that scale. Imagine walking from Italy to Portugal and entering any house as family. No negotiation, no passport, no suspicion. Not because the ants chose peace. Not because they trust strangers. Because, chemically, the strangers no longer register as strangers. The result may form the largest cooperative animal society known. An empire can grow by erasing difference. A defense can work by erasing the defender. On a branch in Borneo, a small worker faces something larger. It does not run, it breaks itself open. These are exploding ants, including Colobopsis species. Their workers carry enlarged glands filled with sticky yellow toxins. When a predator presses too close, the ant grips, contracts its abdomen, and ruptures its own body. The fluid coats the attacker. The defender dies. Scientists call this autothysis. Plainly, the ant spends its life as a weapon that fires once. Remember the billet ant's pain, the trap-jaw ant's speed, and the Dracula ant's scarred nursery. Those all keep the body intact. This defense trades the body for the colony in a single motion. One worker ends. The nest continues. That feels like the far edge of ant evolution. Workers that explode, colonies that float, jaws that break speed records, societies that stretch 6,000 kilometers. Then comes the ant that turns pain into a message no mammal can ignore. The billet ant, Paraponera clavata, carries a sting that can dominate a human nervous system for up to 24 hours. Its venom contains ponerotoxin, a molecule that interferes with sodium channels. Those channels help nerves switch on and off. The toxin keeps pain signaling when the body wants silence. The sting can bring burning pain, shaking, and waves of weakness. On the Schmidt Sting Pain Index, it reaches the top level, 4+. If one walked across your hand, you would notice its weight. If it stung you, the hand would become the center of the world. This ant does not need a super colony. It does not need a raft. It does not need a nursery full of servants. It makes one body impossible to ignore. But the final lesson is not pain. It is scale. Because ants do not show one way to live. They show thousands of ways to turn smallness into power. More than 15,000 described species. More than 15,000 experiments. More than 15,000 answers to the same ancient question. How does a creature smaller than your fingernail build something that survives floods, predators, disease, hunger, war, and time? A colony can become a farm, a furnace, a raft, a prison, a hospital, an empire, a weapon. Most of it happens under leaves, inside logs, beneath sidewalks, and in the black space under your feet. The next time an ant crosses a floor, it may look too small to matter. But somewhere in its family tree, there are farmers carrying medicine on their skin, soldiers that starve beside food, workers that murder the young of their masters, and mothers that drink from their own children. You have seen what ants can do. You have not seen what it feels like to live inside the colony.